All right, welcome to the Explainer. Today, we're going to pull back the curtain on a kind of hidden language that powers AI. It's something most of us never even think about, but it's secretly deciding whether your favorite apps actually get what you're saying or if they're just completely lost. So, have you ever had this happen? You type something super simple into an AI app, something that seems totally obvious, and it just gets it completely wrong? Yeah, you're not alone. And the reason why is this fascinating, kind of weird glitch right at the very foundation of how AI understands us. And look, this isn't just about your everyday chatbot getting tripped up. We're talking about really sophisticated stuff here. An engineer at Cybernetist was building this advanced e-commerce AI using a powerful system called RAG that lets the AI look up product info. But it was a total mess. For some customer questions, it worked like a charm. For others, it was useless. So what was going on? What was causing this bizarre inconsistency? The culprit, and it's something that's at the core of pretty much every large language model out there, is a process called tokenization. This is the hidden language of AI. All right, so what in the world is tokenization? Let's dive in and break down how our words get translated into something a computer can actually work with. Okay, so if you're in the world of natural language processing, or NLP, tokenization is like step one. It's absolutely fundamental. Before an AI can even begin to think about your request, it has to chop it up into smaller, more manageable pieces. And we call those pieces tokens. You know, at its heart, it's really this simple. The AI doesn't read a sentence like we do. It sees a list of these little pieces. Simple enough, right? But here's the kicker. The real story, and where all the problems start, is in how the AI decides where to make those cuts. This is where things get really clever. A lot of modern AIs use something called Byte-Pair Encoding, or BPE. Now imagine you give an AI a massive library of text, like tons of books. It starts scanning and finds the most common pair of letters. In this little example, it's AA, and it smushes them together to create a new single token. Then it just keeps doing that over and over again for the next most common pair, building this huge vocabulary. But it's not a vocabulary of words. It's a vocabulary of the most common word parts. It's how the AI learns the building blocks of language. But of course, it's not that simple. Not all tokenizers are created equal. There are actually a few different ways to slice and dice language, and each one has its own benefits and its own big drawbacks. So you can basically group them into three main camps. First, you've got character level. This means splitting every single letter. Super flexible, yeah, but it's also really slow and can totally lose the meaning of a word. Then there's word level. You just split by spaces. Simple, right? But the second it sees a new word it's never encountered, it breaks. And that's exactly why subword tokenization is the standard today. It's kind of the Goldilocks solution. It balances everything out. And even in the subword family, you've got different dialects, if you will. You've got WordPiece. You'll notice it uses those hash symbols to show that a piece is part of a bigger word. Then there's BPE, which is what GPT models use. It often sticks a space at the beginning. Now, these look like really tiny, almost nerdy differences, right? But trust me, these little choices have huge consequences. Okay, so let's connect the dots. How does all this technical stuff circle back to that e-commerce AI that was failing so badly? Well, let's look at what happens when these tokens just break. Okay, here it is. The emoji problem. A customer leaves a review and uses a sad face emoji. Look at what that first model does. Its tokenizer has no idea what that emoji is, so it just throws up its hands and replaces it with this unk token. It means unknown. So all of that negative feeling, poof, gone. Now, the second model, GPT-4o, is a little smarter. It breaks the emoji down into its raw computer code, its bytes. It's better than nothing, I guess, but the AI isn't seeing sad. It's seeing a string of weird numbers and letters. Yeah, that token is basically a black hole for information. It's the tokenizer officially giving up. And that means all the important stuff. The user's frustration, their happiness, their sarcasm, it's just wiped out before the AI even gets a chance to think. It's a massive point of failure. And typos? Oh man, that's another classic way this all falls apart. A customer misspells package, and just look at how the tokenizers freak out. They just shatter the word into gibberish. PCK-AG-G. Seriously? How is an AI supposed to figure out the customer has a problem with a package when it's being fed these totally meaningless bits and pieces? And it's not just about typos. This happens with brand names, with technical jargon, you name it. Gucci gets split into ga and chi. Savoy becomes sav and oi. The the brand identity, the very meaning, is just mangled. So now think back to that e-commerce site. If a customer is searching for a Gucci Savoy suitcase, but the AI's internal dictionary just sees a bunch of jumbled syllables, it's never going to find the product. The search was doomed before it even started. So I know this all sounds like a total mess, right? But here's the thing. Building a good tokenizer isn't just luck. It's a really deliberate engineering process that's specifically designed to try and avoid all these pitfalls. So let's zoom out. Where does this whole tokenization thing fit in the grand scheme of AI? Well, it's a core part of what's called feature extraction. That's just a fancy term for getting your data ready. It's the step where you take messy, raw human language and transform it into the neat, structured numbers an AI needs. And this right here perfectly shows that old saying, garbage in, garbage out. If you mess up this first step, the whole system that follows is built on a shaky foundation. So, building a solid tokenizer follows a pretty clear four-step recipe. You start with normalization, that's just cleaning up the text, making it all lowercase, stuff like that. Then, pre-tokenization does the first rough chop into words. The real magic happens in step 3, model training. That's where an algorithm like BPE chews through a huge amount of data to build its vocabulary of subwords. And finally, you have post-processing, where you add in all those special command tokens the AI needs to understand the structure, like start of sentence or end of sentence. So, there you have it. That's the hidden world of tokenizers, clicking and whirring away behind the scenes. But what's next? What does the future hold for this absolutely critical, but let's be honest, often frustrating, part of the AI puzzle? You know, this quote really captures the dream, the holy grail for a lot of AI researchers, to one day just throw tokenizers away completely. The goal is to build models that can just read raw text, bytes, characters, everything, without this clunky, error-prone translation step. I mean, think about it. If we could do that, an entire class of AI problems, typos, weird characters, you name it, would just vanish overnight. But we're not there yet. So until that day comes, we're living in a world that is shaped by these invisible rules. So the next time your favorite AI seems just a little bit off, or gets confused by something simple, you'll know why. It might just be speaking a slightly different language. And that leaves us with a question, doesn't it? What other hidden rules are quietly shaping your experience with AI every single day?